Hello, welcome to our Blaze Forge setup tutorial. In this video, we'll guide you through the process of setting up Blaze Forge in your Unity project. First, make sure you have a new Unity project, version 2021.3 or above, and are using either URP or HDRP. Once your project is open, navigate to the Package Manager and import Blaze Forge. Make sure to install the dependencies. This makes sure we have the Burst, Collections, Mathematics and Visual Effects graph packages installed. In the Open Sample URP scene, let's add a cube primitive to work with. Next, we need to add Blaze Forge Master to the scene. Go to the menu and select Blaze Forge. Add Blaze Forge Master. The Blaze Forge Master is responsible for handling the visual effects and simulation between objects. You can customize the visual effects of the fire and smoke by adding a VFX profile. Right-click in the project window, go to Create, Blaze Forge, add new VFX profile. This allows you to specify the sprite sheets, flipbook size, frame rate, scale, velocity, and other simulation values for each layer of fire. Spread height difference lets you tweak the vertical spread of heat and fire. Fire points process per frame tells Blaze Forge how many nodes per object to process per frame. Optimize is a value from 0 to 1. This optimizes the nodes to visual effects conversion. Now let's explore the Auto Lights feature in Blaze Forge. With Auto Lights selected, it uses size and clustering to generate and scale lights based on each node's ignition intensity. This intensity is calculated from the heat ignition temperature and max temperature. The curves in the Auto Lights settings allow you to control light intensity, range, and vertical offset. These values depend on the light's size, giving you precise control over the visual effects. By adjusting the curves, you can create various lighting variations, from subtle flickering flames to intense infernos. The range of values is determined by the light's size, providing customization options. Now, let's add a Blaze Forge part to our cube. To do this, go to the menu and select Blaze Forge. Add Blaze Forge part to the selected object. This will attach a Blaze Forge part component to the cube, enabling it to interact with the fire simulation. The Blaze Forge part allows the cube to respond to heat and fire propagation within the simulation. It acts as a crucial component in creating realistic fire behavior, ensuring that the cube burns and reacts authentically. A collider is not required for Blaze Forge to work. To get the object ready, we just click Generate. Select Show Nodes and increase Node Visualize Size to visualize. This is the only required step to get an object ready. To demonstrate, we will check Auto Ignite and hit play. The Blaze Forge part offers two essential settings, density and face area influence, each contributing to the overall density of the fire simulation in unique ways. With the face area influence setting, you can influence the chance of a node being placed based on the size of the face area. This means that larger faces have a higher probability of hosting nodes, while smaller faces are spared, resulting in a more accurate representation of fire spread. On the other hand, the density setting complements the face area influence by increasing the density of nodes based on the availability of faces determined by the face area influence setting. As the density increases, the fire simulation becomes more intricate, capturing the intricate details of fire propagation. Let's delve deeper into the features of the Blaze Forge part. Collision layers. These layers are utilized to test for collision between nodes and their neighboring objects. A collider is typically required only in scenarios where collision detection is necessary. Default flammable profile. This setting defines the default profile for the generated nodes. We will discuss more about custom profiles later, which offer advanced control over each node's flammability characteristics. Nodes per frame override. This option allows you to override the fire points per frame setting in the Blaze Forge master. Adjusting this value can affect the rate at which fire points are processed, enabling fine-tuning of the simulation's performance. Max neighbors. This parameter determines the maximum number of neighbors a node can have. It influences the level of interconnectedness within the fire simulation, impacting the spread and behavior of the flames. Max search distance. Here, you can define the maximum distance at which a neighboring node can be detected. This distance influences the range within which nodes interact and affect one another, contributing to the realistic propagation of fire. Cluster threshold. The cluster threshold specifies the minimum distance between any two nodes. Adjusting this threshold can control the clustering behavior, influencing the density and spread pattern of the fire simulation. Fire point offset. This setting determines the offset of each node from the face on which it is generated. It adds variation and depth to the fire simulation, enhancing the visual realism. Max external nodes. The max external node setting limits the number of nodes that can be processed from other objects. It helps manage performance by regulating the influence of nodes from external sources. Now, let's proceed to the next step. First, turn off Auto Ignite in the Blaze Forge settings. Then, we'll add a Blaze Forge source object to the scene using the menu. Follow the steps. Blaze Forge. Create Blaze Forge source. The Blaze Forge source script is a versatile component that can be added to any game object to define it as a source of ignition or extinguisher for the fire effect. It has a significant impact on the nodes within its bounds. Take a look at the following fields. Igniter indicates whether this source can ignite a node. Extinguisher indicates whether this source can extinguish an ignited node. Temp modify, value that defines the temperature modification for this source, influencing the heat of the nodes within its bounds. Fuel modify, value that defines the fuel modification for this source, affecting the amount of fuel of the nodes within its bounds. Continuing our example, we will set the radius of the source collider to 0.3 and place it at one corner of the cube. We will also check Igniter. We once again enter play mode to see the effect. If we selected the master, and adjust, optimize, you will notice we can optimize and simplify the VFX. We will increase heat transfer rate to see the spread better. And there you have it. We conclude this video here, but stay tuned for the next exciting installment where we'll dive into Blaze Forge areas, profiles and runtime generation. These powerful features will take your fire simulations to the next level, offering even more control and customization options. Get ready to unlock the full potential of Blaze Forge. Don't forget to like, subscribe, and hit that notification bell to stay updated with our latest tutorials. Thank you for joining us, and we'll see you in the next video.